One of the ways that we can add movement to an object in Construct 2 is using the sine behavior. Let's take a look at how the sine behavior works and what it can be used for. So far, we've looked at how we can control an object with the keyboard, and we've discussed the bullet behavior, which is only used to move an object forward. With the sine behavior, we can control an object's properties using an oscillating sine wave. Here's an image of a sine wave. Basically, each point on the timeline represents a value. The wave's value rises over time until it reaches a maximum value, and then it falls until it reaches its lowest value. We can use the value this wave produces to change an object's size, position, or angle back and forth according to the current value of the sine wave. Let's take a look at some examples so you can get a better idea of how the sine behavior works. First, we need to add the sine behavior to this ghost object. With the ghost selected, click on Behaviors, then click on Add New, and select Sine under the Movements category. The first property of the sine behavior is Active on Start, which is set to Yes by default. Setting this to No will cause this behavior to be disabled at the start of the layout, and you can then enable it later when you need the behavior to start. The second property is Movement, and this is the property that lets us choose what value we want to modify with the sine wave. By default, it's set to Horizontal, which will move the ghost forward and backwards, repeating forever. If I preview the layout, you can see how the ghost moves forward and backwards. As the sine wave increases in value, the ghost's horizontal position, its x value, is increased, moving the ghost forward. As the sine wave's value decreases, its x position is decreased, moving the ghost backwards. We'll take a look at the other options under movement after we talk about the other properties. The next property is Wave, which we'll also talk more about in a moment. After that is Period, which determines the duration of one complete cycle in seconds. So it's currently set to 4 seconds, which means that from the starting value, it will take 1 second to reach its highest value, 1 second to return to the starting value, 1 second to reach its lowest value, and 1 second to return to the starting value, completing one 4-second cycle. If we cut the duration down to 2 seconds, each stage of the cycle will take 1/2 of a second, and the ghost moves back and forth twice as fast. The next property is Period Random, which is a random number of seconds added to the period duration. This is only useful when you have more than one instance of an object on the screen at the same time. What it does is, at the start of the layout, a random number will be added to the sine wave's period, causing each instance of an object to complete one cycle over a different duration of time. If I drag out a few more ghost objects and preview the layout, you can see how they each move in unison. I'll delete all of the extra ghosts I added, and change the original ghost's period random value to 10. So a random value between 0 and 10 will be added to the duration of one cycle. I'll drag out a few more instances of the ghost, and preview the layout again. This time, they're not moving in unison. Each ghost has a unique value for its period. Let's delete the other ghosts, and then set Period Random back to 0. The next property is Period Offset, which determines at what point in the cycle the object starts at. It's the time in seconds that have already passed in the cycle when you start the layout. Let me drag out one more ghost, and I'll set the period offset to 1. Remember that since the period is 2 seconds long, it takes 1/2 a second to reach its max value, and another 1/2 a second to return to its original value. At that point in the cycle, the value will lower until it reaches its lowest point. The first ghost has a period offset of 0, so the cycle starts at the very beginning, moving forward for 1/2 a second. But the second ghost has a period offset of 1, meaning it will start moving in reverse, halfway through the cycle. If I preview the layout, you can see how each ghost starts at a different point in the cycle. The first ghost starts at the beginning of the cycle, and the second ghost starts halfway through the cycle. Period offset random is similar to period random, except it adds a random value in seconds to the period offset value. This causes the object to start at a random point in its cycle. The next property is magnitude, which is the maximum value that will be added to or subtracted from the value we are affecting. For example, I have magnitude set to 100. Since we're affecting the position of the object, this value represents pixels. That means the ghost object will move forward 100 pixels from its starting point, and move 100 pixels back from its starting point at the high and low points of the cycle. Below that, we have magnitude random, which, just like the other two random properties, allows you to add a random value to the magnitude property at the start of the layout. This lets you set each object to a unique magnitude so they don't all move exactly the same amount. Earlier, we skipped over the movement property. Construct 2 comes with an example of the sine behavior in action, where you can see each of the different movement types and how they affect an object. If I preview the layout, we can take a look. First, we have horizontal, which we looked at in the previous example. But below that, you can see the vertical movement option, allowing you to move the object up and down along the y-axis, instead of horizontal on the x-axis. Here, you can see the sine wave alter the size of the object. In this case, the magnitude is represented in percent. The magnitude is set to 25, so the object gets 25% larger, then 25% smaller. If you want, this can be used to control just the width, or just the height as well. You can also control the angle, the opacity, or move the object forwards and backwards along its axis. Last, you can just access the value itself, and use the event sheet to add it or assign it to anything you'd like. The last property that we need to discuss is wave. Even though the behavior is called the sine behavior, sine is just the type of wave that is used by default. There are other type of waves, such as triangle, sawtooth, and square. Each of these waves adds and subtracts to its value based on a formula. Here's the sine wave that we're using. And this is a triangle wave. The triangle wave fades in and out very evenly, whereas the sine wave has more of a curve to it. The triangle wave will cause an object to accelerate at a steady speed, while the sine wave will cause it to accelerate quickly at first, but then slower as it reaches its peak. This is a square wave. It has no curve. It abruptly switches from its maximum value to its minimum value. If I set the ghost wave to square, it will jump back and forth between its max and min positions. There's no in between. Experiment with the different wave types depending on what kind of object you're creating. A UFO might be good to control with a sine wave, while a mechanical platform may look good with a triangle wave. Also, try combining the sine behavior with the bullet behavior. The bullet behavior moves an object forward, while the sine behavior can move an object up and down in a wave pattern. There are lots of things you can do with this behavior, so make sure you experiment and see what you can come up with. Thanks for watching. If you found this content helpful, please consider supporting me on Patreon. Comment, like, and share this video, and subscribe for more tutorials. See you next time.